What's going on, everybody? Storm Chaser Brandon Scott here with WxLive with the latest update on what will be Hurricane Imelda, or Tropical Storm Imelda, for the very least Tropical Depression Imelda. And the next probably update will be upgraded to a Tropical Depression at least. But for right now, it is Potential Tropical Cyclone 9 that we are concerned about. And this storm could have extremely devastating impacts on the Carolina coast. We'll go over that in a minute. This is setting up to be a very weird situation that the models are not having a fun time with, which we'll go over in a second. I think personally, every forecaster out there is basically 50-50ing right now, because even the supercomputers are 50-50ing, the AI models are 50-50ing, and you know, the folks at the National Hurricane Center, as you'll see on their official forecast in a second, have a really wide cone of uncertainty. It is 12:30 on September 27th. We are working on the latest 11 p.m. advisory from the National Hurricane Center. So let's get going here. So the area, so what you see is you have Hurricane Umberto right here, spinning out in the Atlantic. This is going to play a factor in our tropical storm that we're going to be talking about here in a second. Right now it's forecasted to go up and kind of in this direction, near Bermuda right now. So what we call like a fish storm. I don't think Bermuda's in the cone right now. We'll check in a second. But yeah, up and away, or maybe kind of more this way and then up and away. You know, any of these possibilities are out there right now. But our main focus right now is going to be Potential Cyclone 9, or Tropical Storm Depression, or Hurricane Imelda, which is right down here in the Caribbean. And right now it's just a disorganized bunch of showers. Let me get this telestrator off right here and get a better look at her. There we go. So this is Imelda right now. The National Hurricane Center says that the low pressure is right here. So right to the northern coast of Cuba as of the 11 p.m. advisory. Nothing really to note here on the satellite. It's just a lot of disorganized rotation. If you look really closely at the picture from like a wide view, you can see that low circulating. So you can see these clouds kind of up here wrapping around that, and these clouds over here just kind of racing off that way. So you can see there's like a broad area of tropical circulation trying to form into that tropical depression with that defined low, and then a storm and a hurricane. One thing to note here, which is very interesting, which we'll see on the models, as you can see, it's already starting to get into this northern jet stream flow right here. So if you kind of look at these high area clouds off to the left, you can see that it's very different from the low underneath it. So if you kind of look at the area, which is the interesting part of this picture, is you can see these clouds rotating, like these clouds in here and these clouds down here. But if you look, there's like this band, and I'm like drawing all over the screen, this band right here of clouds racing to the north. Right. And that is what is eventually going to take this system and pull it north, because there is a jet stream dip over the United States right now, which I'll show you in a second, that's going to be pushing a lot of air north and a lot of moisture north, which is going to allow this system to go north. So for right now, let's take a look at the National Hurricane Center official forecast track. And this is what I mean by this is not, your average storm. This is not your average forecast, and even the best forecasters, the National Hurricane Center in Miami, are basically guessing here. I mean, look at the size of that area of uncertainty, right? So, like I said, just north of the Cuba, and then they've got it marked here by this time tomorrow, a tropical depression, then a storm as it passes over the Bahamas, storm, and then finally intensifies into a hurricane right off the coast of Jacksonville, Florida, and then a hurricane, and then it kind of just meanders. And we'll see that in a lot of the models that we look at as well coming up. Basically, the National Hurricane Center, you got to remember what this graphic is telling you. This graphic is telling you that the center of what would be Hurricane Imelda, could be anywhere in this circle, say 8 p.m. Monday, 8 p.m. Wednesday, I think is really what the center of this cone of uncertainty is. But the Hurricane Center is saying it could go in right here into Jacksonville, Florida. It could go up into Savannah, Georgia. It could just go this way and completely miss the United States whatsoever or altogether. And that's something that is making this forecast really difficult. So let's look into the factors that are making this forecast really difficult. So this is the latest run of the Euro, the 18Z Euro model run here. Let me make sure you guys can see that. You can. Oh, Telestrator out here. Excellent. So the 18Z Euro, this is, as of right now, this is kind of like present, what's happening right now. So we go forward a little bit. Boom, boom, boom. And you can see that the Euro kind of has this low meandering for a while. I mean, down here off the coast of Cuba. And that's why I think, you know, as it gets longer, these forecasts are going to get refined because, you know, the way this thing is moving right now and the way that it's forecast to move by the National Hurricane Center, I mean, it's not going to meander down. The low's not going to meander down here by Cuba and then kind of like touch the Cuban coast and then decide to finally go up through the Bahamas. So we're coming up through the Bahamas. And then this is where things get really interesting. So this is something that a lot of people are speculating about. It's called the Fujiwara effect. We basically got, you know, two storms so close to each other they want to interact with each other and start kind of orbiting around each other, which is very interesting. And if it was like a true, you know, Fujiwara effect, like basically this storm, or let me get my telestrator out so you can actually see, this storm would want to pinwheel this storm up and around it, and then this storm would want to pinwheel this storm back around it like this. So you would kind of have like, you know, it would kind of be like here, this would throw this hurricane into the coast like this, and then this one would kind of pause and kind of just meander and then go back out this way. That's not really the full picture of like what's going to happen right here. According to the models, this storm, because it's much more intense, much more developed, much stronger, much of a lower area of pressure than Imelda will be, will influence Imelda a lot more than Imelda will influence Umberto. So basically what a lot of the models are now kind of agreeing on just on timing is that basically Imelda is going to stall right here because of the influence of Umberto, because of the jet stream dropping down and this low pressure trough right here, you know, moving all this air this way, right? And then you got Umberto here, and it's basically just gonna just sit there. And then once Umberto kind of gets out and goes this way, it's going to drag it along with it. So let's see how that plays out on the Euro. Okay, so technical difficulties there, we had to cut it. This is the Euro model. So basically it comes up and the Euro is actually showing it stronger than it was earlier, the earlier run today. But then it kind of just meanders. Look at that. So every click forward that you're seeing is 3 hours. So it races north and then it just stops. And this situation, and is what I was talking about earlier when we were talking about devastating, you know, effects for the Carolinas, is awful. So like once you'll see the H wharf here in a minute, where basically the hurricane eye wall just sits there on shore and has like a Hurricane Harvey type effect. I don't know if you guys remember Hurricane Harvey from many years ago, where it just sat over Houston and spun right off the shore for several days, and it was awful. And it basically put the entire city underwater. It was a huge tragedy, big emergency, like very, very bad. And so this would be not great for the Carolinas. I mean, you would almost at this point just want it to, you know, just move, either just go on shore, because at this point it's a weak, you know, hurricane, category 1, category 2 hurricane, hit the shore, turn, go out like every other hurricane does, or, you know, miss altogether. But if it's just going to sit here, you know, it's going to dump rain on those Carolina mountains region that was devastated last year. So, kind of worst case scenario for the Carolinas here, I think, if it just spins off the shore like that. People, they get so focused on landfall, right? Where they're like, you know, well, it didn't make a landfall, so, you know, the winds won't be that bad. And with tropical system, the winds are almost never the problem. They cause, you know, damage to roofs and stuff like that, but it's the water that kills a lot of the time. So you shelter from wind, you run from water. So if it's just going to sit there and dump water on the Carolinas for days at a time, or for, you know, a day at a time, then I don't think it's going to be great. But let's hope for the best. So let's go to the next model, GFS. Let's see what it shows. So same thing, come up. And then you can see, and we'll show you in the ensembles here in a minute why. If Imelda is slower than we think it is, it's going to get a lot more influence from Umberto. If it is a lot faster than we think it is, it's going to get a lot less influence from Umberto. So as usual with these systems, speed is going to determine where things are at a certain time, are going to determine what happens. So the GFS, the latest GFS run 18Z, also keeps it just off the shore of South Carolina here, right around the Savannah, Georgia area, Charleston, South Carolina area. Just kind of races towards the shore and just stops. And then luckily for the folks of Carolinas, it stops, turns around, and goes. It doesn't sit there for an entire day like it does on the Euro. Okay, so on to the Euro ensemble model, and basically what you're looking at here is the different runs that the Euro takes. So every time you see a run of the Euro, say the 18Z, the 12Z, whatever, it doesn't just run one time, it runs a lot of times. It has 51 members of the Euro model, right? And then it takes all those runs, like one run says, you know, it's going to go here, one run says here, one run says here. And so they make a mean out of that, and they that's where the, you know, the actual Euro model is released, right? But this is showing us what all the different members, their solutions, and a lot of times this is illustrated as a spaghetti graph, but we don't have that right now. The first thing you'll notice is there's not 51 members here. Okay, so basically if you see Hurricane Umberto here, you can see there's a lot more red dots on Umberto than there is on this storm. What that means is that the Euro models, a lot of the Euro members are not even making this a storm, meaning they don't give it a dot because it doesn't think it's going to be a significant, you know, low pressure area or a storm. So I would say it's got about half the members even have this thing making it to a storm. So that's why we got to kind of, because the National Hurricane Center is pretty convinced it's going to be a storm. So I would like to see more members at this point in the forecast model, but we'll run what we got. So remember, each dot is what a different run of the Euro said it was going to be on this run, right? Different instance. So as you can see, you know, some of them go on shore, you know, a lot of them go on shore, but you can see that the members that are slower, these members that were further south, so down here with this slow stalling kind of storm, kind of like we saw with the Euro earlier, are the ones that get more affected by Hurricane Umberto here. So you see 1, 2, 3, 4, 5 members just straight up go out to sea. Bye-bye, right? And then you have a bunch of members that, I don't know why I'm pointing at my screen. You have a bunch of members that go on shore here. And you can see all the members that go on shore are the members that are ahead, are faster. So the faster the hurricane, like I said earlier, the less influence Umberto is going to have on it, and it's going to be just like a normal hurricane that hits the shore. The slower it goes, the more influence Umberto is going to have on it, and it's going to get swept out to sea. So, and then you can see after that, it just goes crazy. Wait till you see the Google DeepMind model. Man, that thing doesn't know what the heck to do here in a minute. Okay, so here comes the Euro AI model. So this one difference is like it's not actually simulating the physics from what I understand. It is kind of like the difference between like what an LLM does for speech, right? It doesn't actually talk. It tries to guess the next word. So if you know about LLMs, then you'll know like what this means as far as a weather forecast. So it's using training data, historical previous data to try to predict what this storm's going to do. So you can see right here, comes up the coast of Florida and then doesn't get anywhere close to it and then just goes. But you can see why that is. It's because in this model, it's so slow. Umberto is parallel with it almost when it's down off the coast of the Space Coast, like Cape Canaveral. Whereas in the GFS model, when it's off the Space Coast, Umberto's way over here, you know, south and east of it, you know, not imparting as much influence because it's actually faster on the GFS. And then the regular Euro model, you know, it's also southeast of it. So this AI model is saying, hey, Umberto's going to be parallel. It's going to impact a lot of influence on it, and it's going to yank it right away from the Carolinas, and off it goes. Now, it's worth mentioning the AI model says it's going to loop around and then hit like Cape Hatteras. But this is an AI model. It's very new. It's very far out. I would take that with a grain of salt. Okay, so the next thing is going to be the HWRF model. This is a hurricane-specific model. So what this model does is, whereas the Euro model is trying to model the entire atmosphere of the planet in one run and take all those physics into account, these models they focus on one storm. So here is potential Hurricane 9, or potential Tropical Cyclone 9, soon to be Imelda. And it's kind of like zoomed in, so it's kind of hard to like orient yourself. So here is, where are we here? So I don't even know where I'm at. All right, here's the coast of Florida to the left right here. So as you can see, it has Imelda coming up. Very disorganized system. A lot of dry air wrapping around from the back here, from the jet stream dipping down over the Gulf of Mexico. Very wet storm on the north, very disorganized, going to be ugly. And then finally, once it gets around the Jacksonville area, it starts trying to wrap in some storms and do some intensification. And then you see 981, 979, 978. Now, I will say one thing: the HWRF is not the greatest model as far as pinpointing the location. It is usually pretty good at pinpointing the strength of a storm. So when we look at the HWRF, it does a good job with intensity. So 978, and then look, it just stalls. So here's the eye wall of the hurricane, the most intense part of the hurricane, and this is I'd say the Charleston, South Carolina area, in here somewhere. Here's Jacksonville. I think Savannah would be in here somewhere. And so it's like Charleston, South Carolina. And as you can see, so each step on this one is 3 hours. So starting 5 a.m. September 30th, then you go ahead. So this is already getting the impacts of those kind of inner wall bands there. And then boom, they're getting slammed by the eye wall, and then slam some more, and then slam some more, and then slam some more. And then it's just like, the HWRF is kind of similar to the Euro, where it thinks this look at it. It's just going to sit here and drench this area. I mean, there's going to be storm surge, because you got to remember the way the hurricane rotates is counterclockwise, right? So it's rotating kind of in, I do have this tool, I should probably use it. It rotates in this direction like this, right? And so it's going to take all the ocean water that is here and slam it against the shore right here. And if it does that for hours and hours and hours and hours, you're going to have the same situation that you had several years ago. Or what was it? It was like 2018, 2017, that area where they were having like the Bayou Navy, or like the Louisiana Navy, like a bunch of dudes in fan boats went up to North Carolina and was like rescuing people off their houses. It's this same area that had that last time. And this area is very prone to flooding, because you get this, look at the shape of the shoreline right here. So it's kind of convex. That water is going to have nowhere to go, and it's going to go onto land. Like I was saying earlier, everybody gets concentrated on landfall. The impacts of this storm, if it does this, they're going to be awful. So if you live in the Carolinas, the Charleston area, South Carolina, Beaufort, I would definitely be keeping my eye on this storm. Myrtle Beach, you guys need to be keeping a very close eye on the storm over the next few days. So then after that, it kind of just goes out, and that's a long ways out for this model. So check out the Google DeepMind model. This thing is just absolutely out of its mind. So you can see this is what over here with Umberto, this is what a very traditional hurricane run looks like, where the model runs are pretty consistent on. So if I move it forward here, look, I mean, this is a tight spaghetti run here, man, all the way into this area here, which is, how far out is that? That's Monday, September 29th, Tuesday, September 30th. I mean, we've gotten really good, right, guys, at predicting where a hurricane's going to go, the general area. We're pretty good at it, right? So move your gaze on over to here. All right. The models have no idea what is going to happen with the storm because of the Fujiwara effect, because of this trough that's over the southeast United States. The jet stream is dipping down. You've got the big low over Greenland doing its thing. I mean, it is just a big, huge mess of we don't know what's going on. And as you can see, it's just like the Euro ensemble. So every time they run this model, several models run at the same time. And these are the different solutions that the model came out with. And as you can see, the models that are ahead. So if you kind of like divide your screen vertically or horizontally, the models that are here tend to go onshore. The models that were slow tend to go out to sea. So let's see if that plays out. Yeah. Now the DeepMind, the Google DeepMind is less like, hey, I don't know if that's like, as you can see, there's only like 1, 2, 3, 4, 5, 6 models onshore members onshore for the Google DeepMind, and most of them sweep it out to sea. Once again, guys, the Google DeepMind, very new. It's an AI model, just like the Euro AI model, like an LLM for weather. So these have not been proven. They have not been tested, but I've been following them a lot this year, and they do a pretty good job for most of the storms. So, but it's not something we want to be relying on. Make sure you keep your eye on the National Hurricane Center for all the latest information there. Okay, so yeah, that's it, guys. That is all the information I have for hurricane, soon to be Hurricane Imelda. Or tropical storm, tropical depression Imelda, right now, potential tropical cyclone number 9. That is the latest. We are in storm chasing mode here on WxLive. We do plan on, if it does get onto the North Carolina shore, going out and chasing this hurricane live. So please, please, please give us a subscribe, and you don't want to miss out on that. It's going to be an awesome live stream. We put so much effort into it, and we think it's going to be a great product for you guys. And you're going to have a lot of, great time learning about weather, seeing it live in action. And yeah, that's what we're here for. That's why it's called WxLive and not WX sit in a studio and talk about hurricanes, because I'm obviously not very good at it. All right, guys. Well, thanks for tuning in. That's the latest on potential tropical cyclone number 9. And we'll see you next time. Thanks.